Good afternoon, everyone, and welcome to our latest installment in the Cognitive X ASP.NET MVC webinar series. We're here in our new office, so there's a bit of an echo, just to let you know there's nothing wrong with your computer in that regard. Today we're going to be talking about aspect-oriented programming with PostSharp. Aspect-oriented programming isn't necessarily an MVC specific technology, but it fits very well into the whole MVC paradigm, especially if you follow the solid principles in the area of separation of concerns. So let's just start with a simple introduction as to what is aspect-oriented programming. For those of you who are new, my name is Adam Greene. I'm a software solutions specialist here at Cognitive X. There's my information. Anyways, aspect-oriented programming is a programming paradigm that's aimed at increasing modularity of your software by allowing the separation of cross-cutting concerns. Quite a mouthful, but basically a cross-cutting concern is a unit of functionality within a program that cuts across multiple parts of the system. For example, logging, exception handling, database transaction management. They're spread throughout your most pieces of software, but they're not directly related to the core concept of the system. For example, if you were building a customer relationship management program, your core concern would be managing customer relationships, not worrying about logging and exception handling. Those things, exception handling and logging and all of that, those are cross-cutting concerns. And when you're dealing with separation of concerns, especially like if you're following the solid principles, you'll find that these exception handling and logging, all that stuff, kind of pollute your code because they're not directly related to what you're trying to do, and it's mixed in there with the business logic and everything else you've got going on in your application. And the purpose of aspect-oriented programming is to identify those pieces of code that are that are not part of your core system, and pulling them out into units of functionality called aspects. The reason you want to do that is because these cross-cutting concerns pollute your code through two main areas. One called scattering. If you've ever looked at a basic try-catch block, you probably write the same block all over your code, especially if you're dealing with logging those exceptions. You write the exact same thing like 100 times. You know, try this, catch, log the exception. And it's all over your program. And then when you start doing all of these things where you're dealing with, especially with transaction management, you begin to see what's called tangling, or where different parts of the system and different concerns become sort of meshed together, and it's hard to pull them out. These cross-cutting concerns also don't fit cleanly into object-oriented programming or procedural programming paradigms. So through AOP, you're able to extract these pieces of functionality like logging and transaction management and exception handling, and sort of pull them out into these units that can then be applied to your core concerns later by the AOP compiler or class byte loader, depending on the way in which the AOP software that you're going to be using is implemented. In this case, we're going to be using PostSharp. And PostSharp is what we call a post compiler. Once Visual Studio has compiled your application, it's going to hand off the resulting DLLs to the PostSharp post compiler, which is then going to do some manipulation of those DLLs, write in some new code, add some extra classes, do whatever it has to do in order to be able to implement these cross-cutting concerns into your software. Like I said, we'll be using PostSharp. One thing to keep in mind with PostSharp is because it is a compiler step, it doesn't work with Visual Studio Express because Express doesn't have the same kind of integration points that Visual Studio Standard or Professional and on up have. So you'll need to have, at a minimum, Visual Studio 2012 standard in order to be able to work with PostSharp. Here's the URL for downloading it. So let's take a look at the different aspects that out of the box that are provided to you by PostSharp. Here's the list of the base abstract classes that you'll be using to create your aspects. And we'll look at each one of them individually, and I'll give you a quick example. I'm just going to be using some console applications so that we can get a very simple code base and quick feedback so you can see what's actually happening. So I'm just going to quickly describe these aspects, and then we're going to go take a look at most of them. As you can see, there's 2 or 3 here that we're not going to get into today because they're sort of, frankly, I've never used them. So the first one we have is the on-method boundary aspect. The simplest way to think of an on-method boundary aspect is that it's going to take your methods and wrap them in a try-catch finally block. And we'll see in a minute that there are it calls different methods depending on what stage it is in running the application in that try-catch finally block. The next one we have is the on-exception aspect, which basically deals with exception handling. It doesn't deal with the try or finally part of a try-catch block. It just deals with the catch. And it allows you to also specify within the aspect which exception you want it to handle. So it'll ignore all the other exceptions and only deal with the one that you specify. And if you don't specify anything, it will deal with all exceptions. The next one we have is the method interception aspect. This aspect actually replaces the call to the method that you've decorated with its own code. It also has the ability, once it's done that, to call the original method that it has replaced. And we'll see this when we look at transaction management here in a bit as to how this works. Another couple of good examples is if you want to make a method asynchronous, or especially if you're doing WPF application development, it's a good way of moving a method to run on the dispatcher thread so that you can do UI updates. Next, we have the location interception aspect. This one decorates the properties on your classes and intercepts the get and set. One good use for location interception is the observable pattern, that whenever a property changes that you want to fire an event letting those that have subscribed to the observation to react to it. And that's the observable pattern. Another interesting thing that you can do is with the composition aspect, which allows you to put an interface onto a class that does not currently implement that interface. So if you combine the composition with the iObservable interface and the location interception handling the properties, you can actually make just about any object in your system an observable object. So it's pretty neat how you can do that. An event interception aspect, which works the same way as location interception, but deals only with events. So it handles the add and remove and the invoke of the events. And then we also have the custom attribute introduction aspect, which allows you to add custom attributes to any element of code. And then finally, the managed resource introduction aspect that introduces managed resources into the current assembly that the aspect is in. Just as a side note, when you're creating your aspects, try to, as much as possible, use the on-method boundary or on-exception aspects. because they are the most optimized version of aspects in PostSharp, and they've built the compiler in such a way to optimize those two aspects especially. Okay, so let's actually get into looking at aspects. So we're going to start by looking at the on-method boundary aspect. And like I said, we're just going to be looking at some very, very simple programs. Like here I have a console application. It's simply going to print hello world, and then it's going to throw an exception. Very simple. So if we actually run this, yeah, I'm just going to take the aspects off for a moment and show you what happens without the aspects. So we're going to run our application. And as you can see, it simply said hello world, then it threw an exception. Pretty straightforward. So let's talk about how the on-method boundary aspect is going to work here. So if we go in here, we take a look at our logging attribute. It implements the on-method boundary aspect. Then I have a constructor that takes one parameter, asking if we want to rethrow the exception after we've caught it. Then we have the on-entry method on this aspect. And what on-entry is called when the call, the flow of the program enters the method that has been decorated with this aspect. So it'll call on-entry every time for every time it enters the method. If it successfully processes and doesn't throw an exception, it will then call the on-success method. If, however, there was an exception, it will call the on-exception method, and then in the finally part of our try-catch block, it will call the on-exit. So you're guaranteed that entry and exit will always be called, and then depending on the success state of the method, either called success or on-exception. You don't have to implement all four of these methods for the aspect. You only need to implement the ones that you're interested in responding to. But I put them all four in here so that as we're going through this example, you'll see how it works. As you can see, each one of these methods has a method execution args parameter that gives you access to information about the currently running method. In this case, we're just getting the name off of it. But there's all kinds of things you can find out, like what are the arguments to the method that was called, the exception that happened if there was an exception, the instance, the object that this method is being called on, the actual method that's being called. And then you have what's called the method execution tag. That allows you to store information. It's basically the context for the method that's being called. So in our on-entry, we could set some value that we need for this method. A good example is when we're doing transaction management, and you enter the method, you set up the transaction, and then you can put the transaction object into the method execution tag. And then on success, you can do your commit, or on exception, you can do your rollback. We'll actually see that in a minute when we look at MVC and putting some aspects into an MVC website. One that I skipped over was the flow behavior. Now, there are basically a bunch of different states that the flow behavior can take, and I'll explain what those are. If you have a method that returns a type, or has a return value, if you tell the aspect, especially in the on-exception handler here, that you want it to return, then what it'll do is it'll take whatever the value is of the return and return that. So you can actually, in the on-exception handler, and again, we'll see this when we look at MVC, we can actually change what the return type is. And then you can set the flow behavior to return, or you can choose continue, which is, try to recover from the exception. You can say to rethrow the exception, which then will rethrow the exception that originally brought you into the on-exception handler. Or if you say throw exception, which is different in that it allows you to, for example, go here onto the exception property on the args, change what the exception is, and then tell it to throw the new exception. All right, so that's just sort of a quick introduction to how method boundary aspect works. So let's actually go back to our program and put our aspects on here, simply by applying the attribute to the methods that we want to decorate with the aspect. The PostSharp compiler will now introduce code to insert these aspects into the program. So let's run it, and I'll show you what happened here. As you can see, in simply just saying hello world and throwing an exception, you can actually now see here the trace information that's being outputted by the method boundary aspect. So we have our enter, and then because we've successfully completed the call to say hello, we have the success, and then we have the exit methods being called. The next three are the throw exception method. As you can see here, it says the name. But because we threw an exception, it didn't call the success method on the aspect. Instead, it called the exception. And because I told it to, let's go back here for a moment. I told it to check the state of the throw exception property, which was set on the constructor. And in the case of the throw exception here, I said, don't rethrow the exception. So then what we did instead was we simply told it to continue, try to recover from the exception, which is why my program doesn't actually show an exception happening, because it just threw away the exception and continued running. So that's an example of method boundary aspect. So let's go take a look at the location intercept aspect. So here we have I'm using structure map to do a little bit of setup here, because the example I'm going to do here for a location intercept aspect is I'm going to be injecting services into a class using structure map. So here we've set up our iWriter to return a console writer, which is just it prints stuff to the console. And then in our greeting class, we have a property of type iWriter, and then we've added this inject aspect to this property. And if we jump over and take a look at that, I've overridden on the location interception aspect. I've overridden the onGetValue. There's also onSetValue, and as I said with the method boundary aspect, you don't have to override all of the possible options on these aspects, just the ones that you want to respond to. In this case, we want to respond to the onGetValue. What we're doing, first thing we do is we check the current value to see if there has already been something assigned to the iWriter property. If there hasn't been, then I'm just going to write out to the console so you can actually see when and where this aspect is happening. We're going to write out what's being injected. And then we're going to call the args set new value, and we're going to use structure map to get an instance of the type of the property that's being overridden. That's why we do the location.location type. That is how we find out the type of the property that we have decorated. So then once we've done that, we tell it to proceed with the regular get value, because we've actually injected the service from structure map into the property, and now we're saying continue. continue and actually return the property. So once again, we're going to be setting up the class here and then calling say hello twice. The reason I call say hello twice is I want to show you that it only injects the service once, the first time. So let's run this. Actually, let's show you what happens if we didn't decorate this. I mean, it should be pretty obvious that we're going to get an exception, but let's do it anyways. And what do you know? There we go. Null reference exception. The property wasn't set. So let's go back and put our injector aspect on. And we're going to run it again. And here we go. Injecting aspect.iWriter as the location intercept greeting.writer. And it says hello world twice. So there we go. It injected a service for us simply by putting the inject aspect onto the property. So let's take a look now at, I'm going to skip over an event interception aspect because it's the same as the location interception aspect, just that it deals with events rather than properties. So let's take a look at what's called composition. And what composition allows you to do is to introduce an interface into a class that does not currently implement that interface. So what I have here is I have a class here I've called it empty class because there's absolutely nothing in this class. There's nothing going on. But then I've decorated it with an aspect called introduce writer. So if we go over here, we can see how this is done. The first method you need to override, and you do need to override this one, is the get public interfaces. And this is what's going to tell the PostSharp compiler what interfaces you want to add to the class that's being decorated. In this case, we want to add the iWriter interface. I have this right line here, right line, so that you can see when this aspect is actually invoked. And then we have to override the create implementation object. For whatever interfaces you have said that this class will now implement, you have to provide an object that implements those interfaces. So we have our console writer class that we've seen being used in all our other examples. I'll just take you over there quickly because we haven't looked at it yet. It's a really simple class. It doesn't do a whole lot other than just simply write something out to the console. So both of these methods must be implemented. And so let's go back. And what we see here is we instantiate a new empty class. And then we actually cast it to being an iWriter, which then we call say hello method with, and then we actually call the write method on the iWriter interface. If, for example, we'll go back here and we'll take this off, we try to compile our project, it will succeed, but then when we actually run the program, we actually get an invalid cast exception because my empty class does not implement iWriter on its own. So once we put the introduce writer onto this class, and then we run it, we get hello world. The interface and the object implementing that interface were injected into the code during the post-compiler step done by PostSharp. Let's actually take a moment and go actually look at what's happened to our DLL when the composition aspect was compiled in by the PostSharp compiler. I'm using ILSpy here to reverse compile the DLLs. So if we take a look at the actual program, we have the main method that we saw here before. It's right here. Nothing's changed there. Nothing's changed in there. But if we take a look at our empty class, which before had absolutely nothing in it, now has all kinds of stuff in it. For example, it's now implementing the iWriter interface. And it has a iWriter write method on it now that it didn't have before. And then there's a lot of other stuff on here that's related to initializing the aspects on this particular class. So there's quite a bit of code that gets injected by PostSharp to make sure all of these things work when you run the program. But the big reason, like we said at the very beginning, for doing aspect-oriented programming is that your code itself is very clean. And all of these cross-cutting concerns have been extracted, and they're out of your way so that when you look at the code, it's mostly the business logic that is the focus of the program that you're building. So let's take a look at how we're going to actually use these. Actually, before we go into looking at MVC, I want to talk to you about what's called multicasting. So far, with all of these aspects, I've actually put them into specific spots in my code. But that's not necessarily the most optimum way to introduce aspects into your software. There will be cases where you want particular aspects to be applied across your code base. For example, when we look at MVC, I'll be applying an aspect only to the methods that return action result. So with what's called multicasting in PostSharp, you can define basically a query that will tell the PostSharp compiler where and how and when to apply your aspects. So let's take a look at how that works. We're going to do an example here using the logging aspect that we saw previously if it's done with the method boundary aspect. And by putting this into just any file in your project, it's recommended that you actually create a specific class to put these assembly level attributes on, but I've just stuck it here for the sake of brevity. But call it like global aspects or something like that, and then you put these attributes in. So you put in assembly colon because you're saying this is an assembly level attribute, and then you put the aspect that you want to apply. And then there are a whole bunch of named parameters that you have available to you to define when and where and how to apply this aspect. So we have, like you can see here, the attribute exclude. If you set that to true, then it inverts this rule. So instead of saying where to apply, it says where not to apply. So you can say, to everything that matches this criteria, apply this aspect. And then on the next line, you can do one that's an exclude and say, oh, by the way, but to this method, don't apply this aspect. And then there's priority. You always want to set your, if you need to control the order in which these rules are applied, you can use an attribute priority and just set, the first one as 1, the next one is 2 to set the order of precedence. And then you can say, only in these assemblies, only these types, and you can, the multicast targets, they can be, you only want to do it to properties or methods, to public ones or private ones or protected, or only if they're virtual or not virtual. Like there's a whole bunch of different multicast targets that you can choose. You can say if it's the visibility of these aspects. You can indicate what type of members that you want this to be applied to. You can also say the target members, which, as you can see here, I've said I only want to decorate methods with the name say hello. You can see it right here. I'm saying only target members that are called say hello are going to be decorated by this particular attribute. So there's a whole bunch of different ways that you can specify what to actually decorate with this attribute. Then you can also specify, finally, you can specify specific classes only that you want to be decorated, and which is what we're doing here. We're saying everything in the multicast classes namespace, and then put a dot star saying so we want all the classes in that namespace to be decorated. So the full explanation of this assembly level attribute is that every class in the multicast classes namespace that has a method called say hello will be decorated. So let's take a look at the two classes I have here. I've got a logged class, and it has a say hello and a say goodbye. And I don't know if you can see it on your monitor, but underneath say hello, there's a light blue line. And when I put my cursor over it, this is one of the helpers that the PostSharp Visual Studio integration gives you. It actually tells you what this method has been decorated with. And as you can read there on the screen, obviously. And it even tells you it's been applied by a multicast. And then it even indicates what advices will be used, because we've implemented all four, that all four of them are listed there. You can even go as far as clicking See Enhanced Source Code. Oh, I don't have ILSpy set up within PostSharp, but if you did, it would actually open up ILSpy and jump you right to the decompiled source code of the PostSharp result. So, there's some pretty good tools with PostSharp in that regard. It even opens up and asks me to put it in. I won't worry about doing that right now. They also have a say goodbye method, but it's not decorated because its name is not say hello. And then I have another class. I changed a bit of the wording so that you could tell on the output that what's being called. So again, the say hello, because it matches the multicast, has been decorated, and say goodbye hasn't been. So let's go run. Now I've also introduced some coloring to the output window so that when it runs you can actually see what logging information belongs to which method call. So let's take a look here. So you can see in yellow the logging information belonging to the say hello method. Then you'll see in red the say goodbye. It's not decorated with the logging information because it didn't match the multicast that I set up. It doesn't have a method name of say hello. Then again, on the next one in yellow there, that's from the flogging logged class. And again, because say hello matched the multicast, you see logging information for it. And then again, the say goodbye, no logging information because the name didn't match. So that's what we call multicasting. Now, we're going to move on to actually looking at an example done in MVC using all of these different concepts all kind of mixed together. And the example we're going to look at is managing transactions within MVC. Especially if you're using, like here at Cognitive X, we do a lot of stuff in Hibernate. And in Hibernate needs a transaction to be active in order for you to deal with lists and bags. And anytime where one object causes the loading of other multiple objects, you need to have a transaction that's active. Now, you don't want to have to always remember, okay, oh yeah, I got to start a transaction before I can access my my objects and and do my queries and all of that. You don't want to have to remember that, because that's outside of, like we were saying, that's outside of the core concern of your application. You want to be more concerned about what query and which customers and all of the things that relate to the business logic of your software. And you want the transaction management to be transparent until such time as you actually need to interact with the transactions for any special cases. But for the most of the time, you just don't want to have to worry about that. And that's where AOP becomes quite useful. And what I've done here is I have my home controller, and the constructor takes an I repository. We're using structure map behind the scenes like we did in previous webinars that we've done to set up the controllers when the MVC website is running. So I am injecting using controller injection. I'm going to be injecting an I repository into the home controller. And if you actually look at it, I'm not actually using the repository anywhere in my code. I'm just injecting it and putting it into a private field. Now, the reason I did that is it's kind of silly to do this when we're trying to take all of the transaction management away and just deal with just having to worry about the business logic. Normally you would have more code in here for doing your gets and your lookups and your saves and your updates and all that. But for now, I want to show you an advanced form of multicast. And I'll get to that in just a second. So yes, we have a controller here. It takes an I repository on the constructor. It's going to use it internally. But I want the transaction management to happen outside of this class, as an aspect. So what I've done is I have a transaction aspect here, and it's a method boundary aspect, and we have here on entry. We are going to begin a transaction on entry, and then on success, we're going to commit the transaction. And as I said earlier, with the method execution tag, you can put stuff into it in the entry, as we do here. I begin a transaction, and this method returns an I transaction. So I basically stick that into the method execution tag so that in the success method, I can pull it back out, and then I can actually commit the transaction. Now, in the case of an exception, we're going to pull it out again, but this time we're going to do a transaction rollback. And then here is something as part of dealing with the exception. An exception happened, and we want to now respond in a way that doesn't cause us to end up with that ASP.NET exception error page. We want to gracefully respond to this exception and give the user a nice screen and an explanation of what's happened. So what I did here was I set up a new view result, which is what happens when you say return view from within a MVC controller action. And I've set it to the index, and then I'm accessing the view bag and putting the exceptions message into the view bag. And then on the args that are handed into the exception handler, I'm setting the return value equal to this new view result that I've created. And then I've set the flow behavior to return. I'm just going to quickly jump over the IL spot here and just show you what that has actually done to the within the controllers here, so that you have some idea of why we would do that. If we take a look at this method here, there's a lot of stuff going on here, but the one thing we want to look at is right here. That first thing it's going to do is up here, it's going to call the on exception. And because I set the flow behavior to return, it takes the return value that happened in the onException handler, and it returns that value rather than the original result that would have been returned from the method. So now let's go back up here, because one of the reasons I'm using this aspect is to actually show you how to do a more complex multicast of attributes. So what I've done here is I've said that I want all of the types in the MVC controller's namespace. So that means that over here I have a home controller and an account controller, and so both of those controllers are going to get decorated by this aspect. Now, that's fine in a lot of cases, but sometimes you want to get a much more specific as to which methods or which classes that you want decorated. And what you can do is you can override the compile time validate method on the aspect, which when the post compiler is running, it will load each of the aspects and it'll call the compile time validate on them during that post compiler step. And it'll allow your aspects to decide if they want to be applied or not. So what I'm doing here on this first line is I'm taking the method, getting its declaring type, which will be the controller. I'm pulling out the constructors, and then I'm seeing if there are any constructors that take a parameter of type iRepository. So if the controller has a constructor with an iRepository parameter, then I'm going to say, okay, then apply. And then we're going to take a look at the individual methods on that class, and we're going to see if the result type from that method is assignable from action result. So basically, I'm looking for all the controllers that take an iRepository as a constructor parameter, and then each of the methods that return action result, or something that can be assigned to action result, will then be decorated by this transaction aspect. Excuse me. So that's a more complex multicast that is very specific as to what we want to decorate. So let's actually run our MVC website, and I'll show you how this aspect is going to be interacting with the website. So let me get my web browser over here. All right, so this is your typical out-of-the-box MVC homepage boilerplate. Nothing different there. But if we go back here and we look at the output that's going on behind the scenes, you'll see that it said beginning transaction. And let me see if I can get some more space here. There we go. And then it said entering home controller index. And actually, let's go take a look at this, because I just wanted to show you something here. So here it's entering this action method. I have a public method in here that simply writes out in public method. The reason I did that is I wanted to show you that even though this method is a public method, it didn't get decorated because its return type wasn't action result. So you don't see it down here saying beginning transaction again before it calls in public method. And then finally, when it leaves the index method, it commits the transaction. Now, what I've done in the about action is instead of returning a view, I've thrown not implemented. So if I go back here and I click on about, instead of getting a new page, I should normally get an exception page from ASP.NET. But because of what the changes that we've made to the onException in the transaction aspect, instead what happens, so I end up back on the home page, because like I said, I'm injecting a new view result that sent me back to the home page. And I now have this pink box in here with the exception message displayed. We'll just take a quick look at that page so you can see how I did that. So in the About page, sorry, it's not the About page, that was the one that threw the exception. Here, I have a, if viewBag error is not null, then display the viewBag error. And in here, as shown before, I actually set the error in the viewBag and then effectively redirect it to the home page. And then if you look down here as well, we see that we have beginning transaction because it called the on entry, and then it entered this method. But because it threw an exception, instead of commit, we got a rollback, which matches this method right here. So that is an example of a more complex multicast. Now, there's two more things that I want to talk about today, and that is we've seen with. Let me just get the. I just need to get up my logging. All right, here we go. Okay, so in our logging aspect that we've seen a lot of today, I have a method called trace that is looking at the instance that the logging is running on and make sure that we're actually running on an object and that the method isn't a constructor. Now, this is something that I discovered the hard way. When you multicast a method boundary aspect and you aren't specific as to what it connects to and it ends up decorating a constructor, trying to access the method declaring type will actually cause a Stack Overflow because of recursion. So that's why, just keep that in mind. If you decorate constructors with aspects, it can cause strange activity if you are trying to access declaring type. So that's why I check to make sure that I actually have an instance, i.e. it's not a static method, and I make sure it's not a constructor, so that I set up the logging this way. I'm using an nlog for the logging. Otherwise, I just set up a more generic log, and then finally I log the trace message. Now, the reason I showed you this is this means that every time I enter a method, or as it goes through different states, enter, success, exception, or exit, it's constantly always setting up the logger before it logs the message, which is kind of inefficient. So what I want to do is I want to set up the logger once for this aspect and just use it over and over again. So what I'm going to do is I'm actually going to move the logger setup up here and put it into a method that's called runtime initialize. So I'm going to override the runtime initialize on this aspect. And what this will allow me to do is to add in an initialize. And we don't have to worry about this part because it will always have an instance. But we're going to look at making sure, we still want to make sure it's not a constructor. And we're just going to add this as a field now. Okay, so what, one more change. So what happens with the runtime initialize is that when your program starts up and it pulls in all of the aspects, it's going to call runtime initialize for every instance of the aspect on your program. So you want to be careful that your runtime initialize is very, very small and fast, because it's going to be initializing for as many times as it occurs within the program. The reason it has to do do this runtime initialize is that the aspects are serialized into a resource in the DLL. And when the program starts up, the code that's injected by PostSharp actually deserializes the aspects, skipping the constructor for the method, for the aspect, and instead calling runtime initialize. For example, here on our constructor, we indicate if we're going to, if we want to throw the exception or not in the onException handler. And we're just simply setting a private variable here in the constructor. So since it's skipping the constructor when it initializes the aspects, it has serialized out this value when it did the post-compiler step. So one more thing that we need to add is we want to tell it to not serialize the logger because during the post-compiler step, the logger is actually null, and we don't want to store that into the serialized stream for the aspects. So we have to mark any class, any property or field within our aspect that should not be serialized during the post-compile step. We need to mark it as non-serialized, but we need to mark the overall class as serialized. If you don't, the PostSharp compiler will complain and tell you. So in our runtime initialize, we're setting up the logger. And the one more thing I'm going to do is just put it in a line in here so that you can see when the initialize actually happens. Oh, let's, there we go. So let's go back to our method boundary example here and then I'm going to put in some extra say hellos just so that you can see that it only calls the runtime initialize once on the say hello method. So let's run this. And what you'll see here is there are two initialize. The reason there are two is because we have decorated the say hello and we've decorated the throw exception methods. Like I said, for every instance within your program where the aspect is applied, runtime initialize will be called once. So since we have two methods that are decorated, it's calling the initialize twice, but that's it. And since we've called say hello 3 times, we don't see a total of 4 initializes. We only see 1 for say hello and 1 for throw exception. So that's the runtime initialize. That happens when the program runs. Now, sometimes you may want to do some heavier initialization during the compile stage and store the result in the aspect. Like, for example, if it's kind of a crazy example, but if for each instance of the aspect you need to make a web service call out to some service that returns some kind of information that you need to store within your aspect. Like I said, that's a pretty intense example, but what we can do is we can override the compile time initialize. And what I'm going to do for this one is I'm going to add one more private variable of type datetime called compiled, and I'm just going to set compiled equal to now. So, and I'm going to go down here into our enter method, and I'm going to add just a little bit more information. So now every time it enters a method, it's going to print out the time at which it was compiled. So let's compile our project. And according to the clock on my computer, it is currently 3:29:27, I think. So now when we're waiting a few minutes here. It's now 3:29:40. So let's actually run our program here. And as you can see, the time is 3:29:25. And if I close the program, oops, run it again, it still says 3:29:25. That's because the value of compiled was set when I compiled the program and the PostSharp compiler ran. During that post-compile phase, it called the compile time initialize, set the value of the compile date time field, and then serialize the aspect. So that value is locked in to the aspect. And now until I recompile my program, it's always going to display the same time because that value does not change anymore. So that's what the compile time can do. So if you have any complex calculations that ultimately result in a very simple value that needs to be stored within the aspect, you would do it in your compile time initialize and save that time during your program startup by doing all of the heavy lifting during the compile phase. The last thing I want to show you is kind of a hack that, especially when you're dealing with MVC version 4 and with the new 2013 version 5, the DLLs that make up the MVC framework are pulled in through NuGet, which means that at times the version number on those DLLs can change. And you need a way in which to define some overrides so that your aspects still continue to work. And I actually ran into this problem trying to compile the MVC application when I first created it. Normally, and these were added in automatically but when I create the MVC4 application, you'll see a bunch of, in the web config, you'll see a bunch of assembly bindings. And they're doing a binding override so that any version of, in this case, the .NET OpenAuth Core, any version between 0 and 4.1 will be directed to 4.1. That's fine when you're running the MVC website, but the PostSharp compiler cannot see those overrides. So it actually will throw errors if the DLL version, like for example, I had a DLL version 4 in there because of a NuGet package that I pulled down and messed up the versions on my DLLs. So I needed a way in which to tell PostSharp what the overrides were so that it would play nice. And the only way to do that is to, well, in this case, I added an app config that just contains the binding overrides. And then how you get PostSharp to pick that up, this is where the hack comes in. You actually have to unload the MVC project after you've added the app config. And then you have to edit the MVC project. Then go look for the app config reference, and you change it from saying content to saying PostSharp host configuration file. And then once you've done that and you've saved the project, and you then reload the project, and now when you compile, PostSharp won't complain about any differences in the version numbers on your DLLs. That's a little hack that took me a little while to figure out how to do that. But you'll find with PostSharp, they've got lots of great tutorials and a knowledge base on their website, and that's where I found out about that. And then with some help from some other people, I was actually able to figure out how to implement it. So that's it for our presentation today. Again, my name is Adam Greene. I'm with CognitiveX, and this is our contact information. If you are interested in discussing this further with us, having us consult with you on any implementations with PostSharp, MVC, just about any technology, we would be more than happy to hear from you. You can give us a call, or our email is here, our website, and yep. And Sebastian and Bob just said we'll take 10 minutes for any questions that people might have. Oh, maybe I did. Thanks, Jeff. I just saw your note there. So if anybody has any questions, feel free to type them into the chat, and I will do my best to answer them. Actually, there's one more thing on the, yes, it can be used with Visual Studio 2010. I'm not sure if version 3 can, but there is a version 2.1 out there that definitely does work with Visual Studio 2010. My other laptop here is running 2.1 on Visual Studio 2010. I think 3 can, but to be honest, I haven't actually tried to install 3 on 2010. The example I was showing today was PostSharp 3. Mario, good questions. Well, the logic embedded in the aspects, if you've decorated the classes and compiled, the aspects are actually mixed in to the resulting code. So in a way, it is, if you want to try to separate out the aspects to test them, yeah, you would. The best way to do that is have the aspect use another class to do the actual actions, and then unit test that other class. How much is too much code in the aspects? Well, like I said, the aspects are for the cross-cutting concerns, the things that are necessary for your program to work the way they're supposed to, but are not directly related to the core of your program. Like the example I used to a CRM, if it doesn't have to do with managing customer relationships, it becomes a candidate for being turned into an aspect. And I guess the answer is as little code as possible to achieve what you want your aspect to achieve. I know it's not much of an answer, but the complexity comes down to what it takes for this cross-cutting concern to actually work properly. Peter, is code available on GitHub or somewhere else? Are you referring to the examples that I showed today? Because we will be making this video available, because we've recorded the presentation today. The video will be made available, and I will all of the source code of the presentation that I've done today will be made available as well. Just watch for an email from Sebastian. It'll come through the same channels that you received the email from, LinkedIn or what other ways he sent it out. Oh, there he is. Just yes, it will be put up on our cognitivex.com website. And like I said, we will be making the source code available. I did the examples with the transaction management with dummy classes, so it doesn't even depend on a database. So it'll be fairly simple to spin up this project and be able to play with it in your own Visual Studio. Yeah, we do have several other webinars that we've done on the topic of ASP.NET MVC. So I encourage you to go to the cognitivex.com website and check out our other webinars if you haven't seen them. Any more questions? Yes, okay. I was going to show you something quickly that I forgot to mention earlier. When you create a new project and you want to introduce PostSharp into that project, It's simply a matter of going into Visual Studio and, okay, I'll have to create a demo project just to show you. I'm just going to quickly create a project. So I'm just going to create a class library. So if I want to introduce PostSharp into this new project I just created, I simply right-click it and choose Add PostSharp to Project. And a wizard comes up and it takes you through the steps of adding PostSharp to this particular project. Really all it's doing is pulling down a NuGet package for the version of PostSharp that's installed on your machine. If you also compile a project that has aspects in it and you've forgotten to click that, the PostSharp post compiler will actually pop up, tell you that you've forgotten to do it, and you just push a button and it'll fix any problems with PostSharp in your project. It's the tools for Visual Studio for PostSharp are really quite nice in that way. So if there isn't any more questions, again, my name's Adam Greene from Cognitive X, and we're very thankful that you've joined us today, and have yourselves a great morning, evening, noon, or night, whatever it is in your place in the world. All right, thank you very much.